Sure.
All right, afternoon, everyone. Welcome you to this 4:30 session, tutorial session with Philip Pipes. Going to be talking to you about Let's Encrypt, which is one of the more efficient ways today to keep your websites, your web resources, your online presence more secure, as verified by DNS in an automated way that can renew itself every year without you having to think about it. So that, I'll hand it over to Philip.
Hello, everyone. This is not how I was expecting to teach. I was not expecting to loom in front of you. This is either going to be a very short tutorial or a very long one, and that is all up to you. I plan to talk at slides for the next 20 to 30 minutes or so. And then I will switch to showing you my automation setup and my configuration files, which I've edited a little bit so as not to project any secret keys on the internet. But I would really like everyone to, ask questions and tell me, how can I help you? Help me help you. Don't be afraid. I don't bite. You're all very spread out. That's okay. So let's get to the slides. The title of this slide is Let's Encrypt and Automate All the Things. The important part of this slide is not the Let's Encrypt bit. It's the Automate All the Things bit. When I originally wrote this presentation about 5 or 6 years ago, the internet was a different place and not everyone was encrypting everything yet. In 2023, I think most people are on board with encrypting everything. It's become increasingly rare to see a web page that does not have an encryption on. So I'm not here to convince you to use Let's Encrypt. You're probably already using it. What I'm trying to convince you of is automate it better, and also to fix the encryption gap deeper in your network for things like printers or things like little IoT devices that really shouldn't be exposed to the naked internet without, sharp teeth in front of it. So I will share my DNS workflow on how I do this in my network. My network is weird and crazy and different from your weird and crazy network. So let's, once I'm done with showing you my network, ask questions and help me help you. So, right, the common process of getting a certificate is the same, has been the same for many years. You generate your certificates. you build something called a certificate signing request, which is a blob of incomprehensible X509 data, usually base64 encoded. And then you convince a certification authority, also known as a CA, to sign this certificates, and you repeat this every year. So historically, you generate your certificates once, you give it to a certification authority, usually pasting it in some web form, clicking some boxes, and then handing them a wad of cash. And they would give you your certificate back. And every year, they would send you an invoice to do this process again. Basically, what you're doing is you're renting integers. You are giving them money to sign your certificates. All you're doing is renting some numbers from them. You're giving them money for that process. This is a fundamentally flawed system, right? So the certification authorities are answerable to their shareholders. They're not answerable to you. They are in the business of making money. They are not in the business of securing the internet. They don't care about your network. They care about their cash flow. That's about as much as I want to rant about that today. Ask me more about this at the social event if you'd like. But more importantly for this presentation is that anything that happens annually tends to happen manually. And anything you do manually, you are going to do wrong. So your process might have 100 steps. You're going to get the first 90 steps correct every single time. And then the last 10, you're going to do out of order, or you're going to forget a couple. And it's going to be a huge headache. That's one thing. It's error prone. But more importantly, it is easy to forget. Anything that you have to do annually, you have to set a calendar reminder, and you might set it a week in advance, and then you go, oh yeah, I still have a week. And then you put it off for another couple of days. And then 5 days later, you realize, oh yeah, I should probably do that. And then time zones kick in, and what you thought was tomorrow is actually yesterday. And suddenly nothing is secure anymore. It's easy to forget, and you're just, unhappy time. So when I last gave recent-ish example, when I last taught this presentation, I think it was at KenyaNog or WandaNog or somewhere. The day I was putting these slides together, I went to their webpage to, when am I actually teaching? What time is my session? And I got this wonderful warning saying, certificate expired. They've not, they have not renewed their certificate. So that was kind of funny. I was very pleased to see that today, when I was trying to find a recent example to update these slides, I couldn't find one. So I went looking all around the internet. I tested every single web page on the internet, and I couldn't find a single one that had an expired certificate. This is good. Maybe that means everyone is automating, and I'm preaching to the choir. That makes me very happy. But I'm sure there are still web pages out there, and I'm sure everyone has seen this warning message several times before. Certificate expired, human automation failed, much unhappiness override, and that just that enforces or encourages bad user behavior. You start to ignore warnings, and then when something is really bad, you've trained yourself to ignore it. That's not good. That was the same example. So let's talk a little bit about how we can make this process better. Instead of renting integers from certification authorities, first of all, let's take away the cost element. And that's where Let's Encrypt comes in. Let's Encrypt is a non-profit certification authority. It's been around for several years now, and it's trusted in every system that matters. So every web browser, every operating system, every device that checks for certificates validity or trustworthiness trusts Let's Encrypt's root certificates. So it's free, it's ubiquitous, it's everywhere. But more importantly, it's automatic. The Let's Encrypt forces you to automate by keeping your certificate lifetimes short. Unlike the companies renting you integers for a year at a time, Let's Encrypt gives you the integers for free, but only for 90 days at a time. So everything, if you need to renew your certificates manually every 90 days, you're not going to do that. That's a full-time job. So it forces you to automate it. You must, the cost of getting a free certificate is a little bit of your time to automate the process. Let's Encrypt has other good things going for it. It's obviously secure. It's transparent as well. They publish a log of every certificate they issue. So if you like, you can go and monitor this log and see, hey, has someone been trying to issue certificates in my name? It's transparent. You can keep an eye on this if you like. It's an open and cooperative organization. They have a feedback process. The protocol is an IETF RFC. They take feedback, they take comments. There's a lively discussion group. This is a normal internet sort of phenomenon, unlike the traditional certification authorities from yesteryear. This is a part of the internet community. These are friends, and these are people you could work with. There's an alternative. I don't speak for Let's Encrypt. I have nothing to do with them. I'm just a user. There's an alternative to Let's Encrypt called Zero SSL, which implements the same process as the original Let's Encrypt. They have a free plan, which is substantially identical to Let's Encrypt. So they use the same protocol. You get unlimited certificates, and you can issue them in exactly the same way as you would Let's Encrypt. It's just a different host name of the robot on the other end. They do also have some more expensive plans where you're not renting integers from them, but you're renting monitoring from them. So if you're motivated enough to set up your automation, but you're insufficiently motivated to then go and set up monitoring as well, you can use Zero SSL and give them some money to monitor your setup for you. That's kind of nice. They also have some other things like APIs. If you don't like the ACME protocol for whatever reason, they have some alternatives. And they've got a technical support line. I hear you can phone them and they make you feel better. And they might help you fix your problems. Right, moving swiftly onwards. So how does this protocol work in detail? It's actually quite simple. You are on the left side, you are your web server administrator or your printer administrator, something administrator, and you need to prove to the robots, to Let's Encrypt, that hi, I'm the owner of, or I'm in control of example.com. The robot, Let's Encrypt, then goes and says, okay, fine, that's cool. I will believe you if you put this random set of numbers in this random location on your web server. You go and do that. The robot goes and checks, is that random string of numbers in this random location? Yes, great, wonderful. I issue your certificates. It is valid for 90 days. Go forth and encrypt. 90 days later, you run through this process again. Here's a different set of numbers. Are you still in control of this name you are asking me to sign? Yes, you are. Okay, great. Here's a certificate for the next 90 days. Go forth and encrypt some more. Easy. The problem here, of course, is that it's all web-based, right? You need a web server to sit there to answer this address. And while a web server, web servers are everywhere, but your printer web server should not be exposed to the naked internet for all sorts of good reasons. Printers have heating elements in them and catch fire. Your random IoT devices should not be exposed to the internet for the same good reasons. They can catch fire. Also, there's probably parts of your network that you don't want to expose to the naked internet. Paul Vixie just gave a talk about firewalls in the opening session a couple of minutes ago. You don't want to run a web server on everything. You don't want to expose all your internal infrastructure to the naked internet. So under the hood of this ACME or this Let's Encrypt protocol is an RFC, a protocol called the Automated Certificate Management Environment. The protocol itself is a JSON-based protocol running over HTTPS. So the thing asking for a certificate needs to speak HTTPS, do something on the internet, run by Let's Encrypt or run by Zero SSL. And there are several implementations of that. And in addition to the web mechanism I've just described, there's also several other mechanisms of proving that you own example.com, that you own this name. So this is the web-based mechanism, which is the default mechanism and the easiest to implement for a website. You run a web server, you put a string of letters and numbers at a random address, and it goes and checks and issues a certificate. There's other mechanisms in this RFC, in this protocol, that you can use to prove control over your domain. The one I'm going to use later on in this presentation is DNS. The web is one option, DNS is another option. I think there's a couple of other options. There are several implementations of this protocol. So there's the default reference implementation called certbot, which I'm sure several of you in the room have used before and hate with a passion. It is a pretty big application. It's reference implementation. It's got many dependencies and unfortunately also makes many assumptions about what you're running on. So it assumes that all the world is a Linux and that every web server is called Apache and that everyone sticks their website in the same place. That's nice for a reference implementation, but it's not great for more generic solutions, which is what we are here to talk about. So the implementation I'm using in this tutorial and later in my demo is called acme.sh. It's a tiny, tiny shell script. I've read through the whole thing. It's not difficult to understand. It has no awkward dependencies and it just works. There's several others. When I last looked at the list of clients, wow, 3 years ago now, or nearly 3 years ago, there were over 100 different clients. So there's one, there's one to fit every need or every every wish or hope and dream. And you can also write your own implementation if that's what you want to do. It's an open protocol. It's an RFC. Nothing to be afraid of. But for this tutorial, I'm going to talk about acme.sh. Moving swiftly onwards. There we go. So in a nutshell, you clone, to install this ACME shell script, you just clone their Git repository and you run the shell script itself, and it's going to install itself on your machine. It creates a directory. It creates some aliases so you can run it without having to type long strings of commands. And then it sets a daily cron job to check and renew certificates. So every night, the little script, the robot will wake up and go, are any of my certificates due for renewal? And it goes and asks and runs the little protocol with Let's Encrypt or with 0SSL to ask for, please sign me a new one, please sign me a new one, and it will deliver a certificate. This is more or less the same as the reference certbot implementation, except that this is all it does. It is not going to edit your configuration files. It's not going to modify your web server. It's not going to modify your mail server. It's not going to do anything other than here is assigned certificates for this host name. And then you can go off and plug that certificate into your other automation to keep your web server from using the right one. So it's really easy to install and easy to use, and all you get out of it is a signed certificate, which that's all you need to then go plug it to your automation. Using acme.sh is also fiendishly simple. I'll do a quick demo in a bit. Is you just say, dear acme.sh, please issue me a certificate for this domain, example.com, and use the following mechanism to issue the certificate. So the first example I've got here uses the same mechanism as certbot and expects a web server to be listening on that path. And it drops a string of letters and numbers there and speaks that protocol. You can ask for multiple domains at the same time. So, if you have a whole list of websites or a whole list of devices you want certificates for, you can ask acme.sh to issue you all of these in one certificate. And it's very straightforward. It just does it and it just works. There's many, many, many options to the shell script. I would encourage you to go read through it. But the nice thing, and now finally getting into the point of this presentation, the shell script supports different modes of operation. So by default, it does the web-based mechanism, which we've talked about. It also has something called standalone mode, where it will listen on port 80 and it pretends to be a web server. So you don't need to also go and install Apache. You don't need to also install Nginx or any other web server. It will pretend to be a web server for the duration of issuing your certificates. That's kind of nice. Unfortunately, that does require privilege to bind to port 80 on most Unix operating systems. And it still requires a publicly reachable machine. You need to be able to talk to the Let's Encrypt robot or the Zero SSL robot from that machine. So if this is running somewhere deep inside your network with no path to the naked internet, this is not going to work for you. Also, this is a Unix shell script. You're not going to run this on your printer unless you're really weird. People do weird things. But it's still, it'll run on a Unix machine deep in your network. If this is what you need and you're happy with it to be publicly reachable on the internet, that's a nice way to do it. Much nicer is it supports DNS mode, where the shell script is going to add records to the DNS to prove that you own or have control over the domain you're trying to sign. And then it'll remove the records again. So instead of Let's Encrypt checking your web server, whether you have control over the domain, Let's Encrypt is going to check the DNS if you have control over the domain. And DNS is a lot more easy to automate than websites. And also, the DNS server can run somewhere publicly visible in your network. As long as you can get DNS records added and removed, you don't need to expose your devices to the internet. So you don't need to run certbots. You don't need to run acme.sh on each individual device you're generating certificates for. You can have one machine that can talk to the internet and that can talk to your DNS, which does all the certificate management for you. And then your machines deep in your network can get their signed certificates from there, rather than having to run the protocol themselves. They just talk to your own certbot and say, hey, has my certificate changed tonight? Has my certificate changed tonight? And you just run that in your own automation. So instead of having to talk to Let's Encrypt.org or Zero SSL over the internet, all your machines on your network with certificates have to do is they just have to ask one of your machines, is there an updated certificate? That's easier to automate. It's easier to secure, and all sorts of goodness. And that's what we'll talk about in this tutorial. Before I get into the demo and the automation and show you my scripts, I need to digress a bit about limits. Let's Encrypt.org has limits. They're generous, but they are firm. And the very short version of this slide is don't test in production. You're not going to have a good time. So the key limits of Let's Encrypt are, when I last looked at this slide, was 50 domains or 50 certificates per domain per week. That feels like a lot, but if you're debugging and testing and trying to fix your automation, 50 certificates is about 20 minutes at most, and then you run into the robot saying, no, don't test in production, don't do this. Duplicate certificates, it lets you do 5 per week, which again, it's a little bit more difficult to run into that one when you're testing in production, but still, you're going to hit it. Don't test in production. And failed validation, one you'll definitely run into, 5 per account per host name per hour. So you cannot actually test in production because retry, stop. So limits are a thing. Let's Encrypt has a test CA specifically for this purpose without these limits. It'll issue you a certificate just like the real robot, except no one will trust it, which for testing is exactly what you need. So hammer that one instead of the production system while you're testing your automation, and things will go much better for you. How am I doing for time? Oh, I'm doing pretty well for time. So let's talk about this DNS mode. My slides are on the system. I'm going to stop talking at my slides now. There's screenshots of previous presentations I've given with outputs of how this all works. I'm going to start talking at a terminal window now instead of at my slides, because that's a lot more fun. Let me pull that up. Lael madly. Where is my terminal window? And now let Zoom see the terminal window. Does it work? Does it work? Yes, it works. Hooray. So for a quick demonstration, what I'm going to do is I'm going to add a record to my domain. So trouble.is is my domain. It makes sense if you think about it. And I'm just going to add a record here somewhere. I don't know where I'm going to add it. Let's add it at the end. Let's add apricots 2023. Give it a pick up one of my A records. Just give it an A record. I can't type. I've forgotten how to teach. So I've just created a record in the DNS. Apricots 2023.trouble.is will start to exist. You'll see this long list of stuff up here. This is one of my toy domains, and I'm just going to add a CNAME after the same fashion here. And call it ACME challenge dot apricots 2023. And that's a CNAME to here. We'll talk more about what this does in practice later, but I'll just add this to my DNS. Oh, there we go. Oh, this goes to the DNS. So my DNS pipeline is I write to a file, I push it to a Git repository, and I wait about 2 minutes for the DNSSEC automation to kick in. And for those 2 minutes, while that happens, I try to talk and make a lot of noise and flail and hope that someone has questions. Sander, do you have any questions? No. Or I heckle the audience. There we go. My automation just tells me that my configuration has been updated. That's good. And so if I ask the DNS apricots 2023.trouble.is, do you exist? Spell it right. Not SIIS. There we go. It exists. So I've added this to the DNS. That name now exists. That's great. Now I would like a certificate for this name. You know, this host happens to be exposed to the naked internet. I could just change that to be localhost. I could change it to anything I want it to be. But because I like wild demos with web pages that show nice things, I'm just going to use this one here. But this could be the IP address of your printer or something deep in your infrastructure. It really doesn't matter because nothing is going to talk to this address ever. We move on to my certbot, which has disconnected. Oh, no, it hasn't. I am going to just do what I said earlier. I'm going to issue a certificate for that. Oops. Can I type? Why am I not typing? So I'm going to issue a certificate. Dear ACME.sh, dear shell script, please issue me a certificate and use EC256 as the algorithm because it gives you nice short keys, which are easy to copy and paste into configuration files while you're teaching live at an audience and trying not to flail too much. Use a DNS mechanism to validate that I'm in control of this name. So DNS NS update is a little shell script that adds a record to my DNS. Use the certbot.trouble.is alias to validate that this name exists. That matches what we saw earlier in my zone file. And yes. Is there? But if I make the window smaller and smaller, there we go. Young people in the room can read this. So there we go. And this is the host name I want to issue. Mine is the apricot 2023.trouble.is. If I run this command, everything will blow up, right? The room will catch fire. There will be much flailing and madness. Or alternatively, I will soon have a certificate falling out of here. Maybe. So what's happened here is that acme.sh has sent a little message to Let's Encrypt, the robots on let'sencrypt.org saying, hi, some guy in Manila is trying to get a certificate from U for apricot 2023.trouble.is. Please go and check that this guy who's running this command actually has control over that DNS namespace. It'll check a text record in the DNS, which is now hopefully being added. So this has been added, this line here. It's now added a text record to my DNS. So apricot 2023.trouble.is now has a text record which ACME or let'sencrypt.org is going to check. And it's just, it's sitting there trying, and at some point it's going to time out, and then I'm going to retry. And if I try 5 times, it's going to fail. But okay, it should take about a minute or two for this to work. Painstakingly checking. I could just check a log file to see what it's doing. At some point, if I threaten it with looking at the logs, it's suddenly going to work, right? Come on. Yeah, it's my public DNS is run by Hurricane Electric, and sometimes it takes them a couple of minutes to notice my notify. Okay, come on, validate, damn it. You have a better one? Okay, I'm happy to add more. Happy to add more DNS or more servers to my network. Come on, certbots. Oh, it's not troubling me. It's just it's the demo phenomenon, right? When you do this in your room at 8 o'clock in the evening, quietly with nobody watching, it just works immediately. Yes, my slides I've not looked at in months, they just work. And then several hours later, you do it in front of a room of people, and they will watch you while nothing is happening. And I have missed this in the last 3 years, damn it. Come on. It'll get there eventually. I could switch back to my slides quickly and talk while this happens. Yeah, it's sent notifies. It should turn up there soon. Maybe the timeout is set to 10 minutes, but it worked last night in about 4 minutes. It should work. Let me just go back to my slides for a bit while this happens in the background. Give it 1 more minute. Come on, you can do this. Pick this up, damn it. So, yeah, let me go back to my slides. Demos are horrible. If I stop sharing this and just go to my slides, share screen. No, I haven't got. Where's PowerPoint? PowerPoint's here. Start slide. Come on, Zoom. See my slides. Zoom. Here we go. So while this is ticking along in the background, I'll just talk you through the process or the output you're supposed to see. So this is an older slide, backup slide of the process from PACNOG 27 a few years ago. So what's happening here is the DNS validation is happening, and a text record has been added to my DNS trouble.is zone file underneath certbot.trouble.is. Remember that apricot 2023.trouble.is was a CNAME for certbot.trouble.is. So the robot now goes and checks, is that text record under this namespace? And if it is, it's going to issue a certificate. So that's what's happening in the background here. It's still checking. Eventually, this process concludes and the text record will be removed from your DNS again, so you don't end up with a zone file with 1 million random text records. The script cleans up after itself, removes the records again, and what you get out of this script in the end is you get a signed certificate, just like you would from an integer renting certification authority. You just get a PEM-encoded file, which you can then feed to your web server or whatever you like. If this is the first time you've created the certificate, it's also giving you the private key, which you should then securely transfer to whatever system the certificate is ultimately going to end up on. And it's also going to give you the full chain. So it's giving you everything you need to plug into your configuration of whatever device you have at the end, and it's done. What it will do after that is it will keep that certificate fresh forever. So every night, certbot runs as a cron job, and it's going to check all your domains. Do I need to renew the certificate? Yes. Do I need to renew the certificate? Sure. And it goes and runs through this process again. It doesn't change the key for you. So it reissues the same certificate with the same key. So on the end device, the only thing you need to do is you need to feed it the updated certificate at the end of the line. You never touch the keys again. If you want to change the keys, there's an option you can run. And if your company or your personal security policy requires you to roll keys from time to time, you can do that yourself in the system, or you can add a little bit of automation there to do it for you. And that will just work. Meanwhile, this is still running and timing out because it's a demo, damn it. So the way this works is come on, slide. Let's Encrypt.org is checking for ownership by verifying a text records rather than a web page. In my specific setup, there's a bit of indirection. The slide is out of date. I don't put my DNS in Azure anymore. I've moved my DNS. I've made it more complicated. There's some Hurricane Electric in there. There's some shell scripts in there and an additional DNS server. This works with any other DNS provider as well, right? So I've made it more complicated for myself by using my name server and running NS updates and tsync queries back and forth. And that's just my crazy setup. It's been a long 3 years. I have nothing better to do with my life than to complicate my network beyond what any network should reasonably have to bear. If you have your DNS in something like Cloudflare, you can use their API to just add these text records for you. And that just works. It's just a configuration setting. If your DNS is running on any number of DNS providers, there are scripts written for you already. As long as there's some kind of a mechanism, an API or a shell script mechanism for you to put text records into the DNS and take them away again, you can run this. And critically, you don't have to expose the end host that will use the certificate. That never needs to see the naked internet. And acme.sh is going to renew it for you. So meanwhile, good. That was just the right amount of time. I will go back to my terminal because good things have happened. Ta-da! Pretend that 1 minute has passed instead of 10. The script has done its thing. It has spent a long time doing it. But at the end of the day, it has removed my text record again. It said, here's your certificate. And it just prints it. So if you're in demo mode and you just want to copy paste the certificates into something, you can just copy it from here, paste it at your web server. That will work. If we look at this certificate a little, well, it's actually here. If we look at the certificates, X5, text minus, no, out minus in. That one, if we look at the certificates, let's just pipe it to less because I don't know how big my screen is. If we look at the certificates, it's a signed certificate, right? It's been signed by Let's Encrypt.org and it is valid for 90 days. So in 90 days, this needs to be renewed or it expires. You can't do that manually. You'll have to renew it. So every night, acme.sh is going to wake up in cron. Actually, I could just show you the cron tab. Every night, acme.sh runs and it goes through its list of certificates. It goes through its list of certificates and it sees, hey, apricot 2023.trouble.is was originally created on the 27th of February. It is due for renewal on the 27th of April. So 1 month before the certificate expires, the robot is going to try to renew it for you. Why 1 month? Because there's a host on the internet you need to talk to. It might be down. You might have lost your upstream or something. If it fails, it expects you to send an email to yourself saying, hey, I tried to renew it. It's not working. 24 hours later, it's going to try again to renew it, and again and again and again. And hopefully between the 27th of April and the 27th of May, when your certificate expires, you will have seen that email, or something in your monitoring will have noticed that, hey, this certificate is about to expire. Maybe you should kick your automation and make sure that it still actually works. So let me walk you through this shell script a bit, how it works. So inside, oops, I can't type anymore. Inside its directory, I run it as its own user called ACME on this machine. It creates a .acme.sh directory where it installs all of its things. So it keeps an account.conf file with your Let's Encrypt account, which it creates the first time you run the script, just like the reference certbot implementation. It installs itself, acme.sh. It has a little environment, which if you are brave or crazy, you can use to write a wrapper around this acme.sh script to plug it into other automation you may have. CA is the current version of its root certificates, which are part of the chain. It'll copy this into each of your certificates every time it renews them. Deploy is a set of hooks I'll talk about in a bit. DNS API is the interesting bit for this chapter. This contains a series of shell scripts with DNS API implementations the script knows about right now. If you're using a different DNS than any of these, my first question is, why? And you can just write your own scripts if that happens to be the case. So for my sins, I also help run the freebsd.org domain, and we don't fit into any of these boxes. It's possible that you don't fit into these boxes, but you can just write a little script that fits your boxes. It's a very simple interface. So the one I'm using in this current world order is NS updates, if I can find it. So it's a pretty simple little shell script that at the end of the day just calls NS update for you with a tsig key, and it just, morally equivalent to you typing NS updates, your DNS server, your zone, here's my key, add this record, delete this record. So it just calls NS update for you. Another example is the Cloudflare one. Is it called Cloudflare, or is it called CF? CF. The Cloudflare one uses Cloudflare's published API with a token. So you go to your Cloudflare portal, you say, give me a portal that's allowed to update my DNS. You feed that token to the shell scripts, and it will use that API to add and remove text records from your DNS. And the only thing the script needs to talk to is Cloudflare and Let's Encrypt, or Let's Encrypt and your DNS server, whichever DNS server it is. If you can talk to your DNS server, acme.sh can use it to add and remove records. Done. Let's talk about these deploy things. So I have not yet deployed my shiny new certificates, so I will do that now. Let's call it minus EC. C. There we go. So I've now called a deploy hook. In this deploy hook, they live in, deploy. So again, there's a whole bunch of shell scripts in there. They're less likely to be useful to you. Well, they might be useful to you, but not necessarily so. In this script, you tell acme.sh what it should do with your certificates every time it issues it. Where do you want the certificate to go? If you're running this on a web server, a reasonable thing to do might be, well, put the new certificates where my web server can see it and kick the web server process so it starts using it. If you're running the scripts on a mail server, a reasonable thing to do might be put the certificates where the mail server can see it and kick that process. But not necessarily, right? So the way I run it is certbot is just a certificate oracle. The only thing it does is it adds things to my DNS and it goes and generates certificates. So what my little script does, it's called IBIT for hysterical reasons. What my little script does is it just copies the file to somewhere where I can see it. It copies it to, I don't actually remember where it copies it. It copies it to output, which is public HTML. So it's public HTML. Come on. Oops. All right, why am I not able to type? Yeah. Yeah. So there we go. So what it has done is it's copied the certificates to a public HTML directory. So if I now go and ask the internet or just ask my web server, or I think it's called this. There we go. Oh, host does not result. Oh, if I spell certbot right, it'll work a lot better. There we go. It says move permanent. Oh yeah, it wants HTTPS because why not, right? There we go. So my deployment mechanism is I just stick the signed certificates on a web server under my control, and I pull this web server every night for is there a new certificate? Is there a new certificate? So each and every one of my hosts. Let me find one. So this is a host that's sitting at home somewhere. It's on the internet clearly because I can talk to it, but I feel no burning desire to go and run certbot on there. I feel no burning desire to have this thing talk to let's say encrypt.org to generate its own certificates. Instead, every night it just runs a little shell script. Every night it runs a little shell script that goes and checks, this is the machine that's sitting at home. It goes and checks, is there a new certificate for the printer? If yes, do something with it. Is there a new certificate for the Unify Ubiquity wireless access point stuff? And it every night this runs, and at the end of the script, it does things. It sends the certificate to my printer. I have no problem showing you that private key because the printer is obviously not reachable from the internet. So every night it notices, hey, there's a new certificate for your printer. So talk to the printer, mangle the certificates into a way that the printer understands, and then reverse engineer the web interface of your printer to figure out how to upload the new certificates and do exactly that. So my printer has a validating SSL certificate, so I can do IP printing over TLS and all the warnings magically go away. Nothing on my Mac cries, say, you are trying to print to an insecure printer. It doesn't. So it's just my printer has a real world live certificate, and I'm not stupid enough to expose my printer to the internet. The web interface of my printer, likewise, is not exposed to the internet, but it's exposed to this machine. This machine can talk to it and say, here's your new certificate. And that works. It doesn't have to be your printer. It could be your Wi-Fi, your Unify control system thing. It can be anything. It can be your nuclear power station, right? Please don't. But it can be anything you want it to be. Just download your certificates, and then there's some other magic I've got on web servers and all sorts of other things which do something meaningful when they notice a new certificate. So the automation is very flexible. The only key variable is there's a certificate somewhere on a web server which you go and download, and you build your automation from there. Right? Does that make any sense? Let me go back to my slides for a bit. Stop this. It's an HP Danger Fire Catchy model Sparky printer. Yes, it's a pretty standard printer. If your printer is young enough to have a web interface that supports SSL, it will have a way to upload a certificate. That way may not be straightforward. In the case of my printer, it took me an afternoon of tearing my hair out and going, why? Why must you make this so complicated? It does not have something simple like, here's an endpoint you can post a PEM encoded file at. No, I need to go talk some JavaScript and encode it in a JSON object and then throw it at that thing. But each to their own. Other printers might have something more straightforward, and if you're lucky, you don't have to deal with printers. You have something a little more friendly. These hooks, they are very simple shell scripts, right? You can do anything imaginable with these hooks. I choose to just dump my issued certificates in a web server and run my automation on the individual hosts because I think that's easier. I think it's easier to have a certification oracle somewhere sitting on my network and pulling certificates from that, and then every host deciding for itself, hey, there's a new certificate, I will do something with it. I don't subscribe to the philosophy that all automation must be in the same place. My philosophy is that each host is responsible for its own automation, and cron is a thing and it works really well. So on web servers, I go and pull for certificates every night. If the timestamp on the certificates is newer than the process ID of the web server, I kick the web server. On printers, I do other things, and every single host has its own little mechanisms, and I do what makes sense for that host. Right, exactly. So yeah, Sander said you don't need one host that has access to everything in your network. So you shrink your attack surface a little bit that way. And you can make it more reliable, right? You can have multiple certbots if you like. You can go overboard with this. You can stick high availability proxies in front of your certbot web server. But remember, there's really no need because you have a 1 month window of play. Certbots or ACME.sh, every day it runs, and 1 month before the certificate expires, it starts asking for renewals. If it starts, if it cannot get a renewed certificate, hopefully in that 1 month window, some of your monitoring will cry, and you'll notice and you'll be able to fix it. Perfectly reasonable deploy hook, by the way, is you can email the certificate to yourself 1 month before it expires. Once it's been renewed, email yourself the certificate and then you go copy and paste it into a file. I wouldn't recommend this philosophy, but it's something you can do. So if you have a system that is completely air-gapped and hostile to any kind of automation, the worst, the fallback scenario is still there. You can email yourself assigned certificates, which you then go and do something with, or you pay someone to go and do something with. It's the nice thing about this is you have a certificate to do something with. So you have something actionable. Whereas if you have a calendar reminder once a year that says, go and renew your certificates, you're going to push that off indefinitely because, it's going to be pushed off. And then, one year since the last time you renewed your certificates, whoever is selling you your certificate has changed their mechanism, and you'll have to rediscover the process. And it's not going to be fun and error prone. Whereas this, if you have to email yourself a certificate, you still get the actual certificate immediately. You have something actionable which you can take to whatever it needs, and the process is a lot easier. If you don't want to automate your web server, it is a lot easier to copy paste a certificate once every 90 days than it is to fight with some web portal on the internet once a year. It's less easy to forget, and it's immediately actionable. certbot runs every night, so you could have a cron job that emails you that certificate every single day until you have replaced it. That's up to you. You build your own adventure. And all of these things are just shell scripts. So you are limited only by the imagination and by your ability to write shell scripts, which is kind of nice. The rest of the slides are a bit bonus slide fodder for people using Azure and Cloudflare. The process is more or less the same. All you need to do is find a way to add text records to your DNS, and the rest just is done for you. Yes. Yeah. Yeah, that's well, so that's where it gets interesting. It's been a long 3 years. So what I do, let me stop sharing and show you. That's a good question. Thank you. Let me show you what I do. Let me share the correct window again. Where's my window? Here's my window. What do I type at this? I'll go, where do I go? I'll go here. Oh, give me another window. This window, that window. So what I do here is I create this CNAME. So ACME challenge .apricot 2023 is alias to ACME challenge.certbot. Yeah. So certbot.trouble.is. Actually, why don't I just ask the DNS? The first line is not interesting. What's interesting is the way it works. So certbot.trouble.is is delegated as a separate zone. So it's not part of my organization's DNS as such. It happens to run on the same DNS server, but it's a separate zone. So if acme.sh loses its tiny little mind and decides to go and delete every record in the zone, the only zone it can delete records in is the certbot zone. It cannot delete everything else under my namespace. Yeah. You just have to reload your zone file. So you or do whatever your DNS server wants, right? So in my case, my DNS pipeline is hideously complicated because I'm a horrible man. So I have some other automation which notices, hey, the DNS zone changed. Go in the DNSSEC, sign it, and then the signed zone ends up on my fan out system, and then eventually my published DNS servers pick it up. You can make this as complicated or as simple as you want. At the end of the day, the only thing you need is Let's Encrypt needs to see a record in your DNS. How it gets there does not matter. Yes, I sign that zone because, if you're, if it's worth doing, it's worth overdoing, right? Yeah. You can, but wildcard certificates they have downsides. It means every host that has the wildcard certificate has the private key of the wildcard certificate. So your funny little IoT device, which has been made by well-meaning but incompetent fools, now has your private key on it and then goes and uploads it. And it's no longer a private key, but a public key. And it's now the public private key for your printer, which can catch fire. So wildcard certificates they're easy, but they have downsides. And with automation, you don't need wildcard certificates because it's really easy to add more certificates. You run an issue command and you get one, and files don't cost anything anymore. So the certbots, your little certification oracle, it doesn't care if you're renewing one certificate or 1,000.
I actually walked over to the microphone, so you don't have to repeat everything I say.
Sorry, I don't.
But yeah, one case I actually noticed where you cannot use wildcard certificates is if you want to have certificates for your VMware servers, for example. Because if you in vCenter try to import a wildcard certificate, it will actually die because it does not support wildcard certificates. So there are cases where wildcard certificates just won't even work. So it is also the way to do this with DNS is the only a way to get a wildcard certificate anyway.
Yeah. So yeah, that was a wildcard digressions aside. There's a lot of pointers at the end of this slide deck if you want to go and look. But the key takeaway message for this tutorial is that DNS is really, well, DNS is horrible and complicated, but DNS is well understood and DNS is really easy to automate. If you've got anything more than the most trivial of networks, you will already have some kind of automation around your DNS. So you don't have to go and reinvent the wheel to issue your certificates. You can leverage your existing DNS automation to just stick your certificate issuing on top of it. And I think this is better than running, a hideous shell script or certbot or reference implementation and a web server everywhere in your network. I was chatting with someone last night about their setup, and so I issue my certificates, and every month when I have to redo my certificates, I have to poke a new hole in my firewall. So he'd gone around, another way. He'd been automating his firewall, so he's still got certbot running on each individual machine deep inside his network, and every night he pokes a hole in the firewall so let's encrypt.org can talk to that machine deep in the network. That works, but I would argue that that's the wrong way around. It's a lot easier to stick it in your DNS, which the internet has to see anyway. And you can add a layer of indirection so you don't expose your top namespace. Just add delegate certbot.your.org to some other DNS server and restrict it to there. And then you can do what I did. So I do that, and then I go overboard. I don't need the internet to speak to my DNS server. I can just, use my published DNS servers to fetch the zone from there and have a hidden master, and that works well. So my DNS server, my own DNS server, the source of truth, is not visible to the internet. The only DNS servers that can fetch my zone are my published primaries. So my attack surface is shrunk even further. And it's been a long 3 years. What else do you do with your time? Automate all the things, and I can keep shaving this yak. Well, at some point the query needs to get a reply, right? So someone somewhere will need to give an answer to that text record. How it does that is open to as much complexity as you like, because that's the nice thing about DNS. It's perfect sense. Yeah, exactly. You just you add their host names to the DNS. You CNAME them to your certbot, your Oracle, your whatever you want to call it. Once a night, it goes and issues certificates for all of them, and then those private IP addresses just have to fetch their certificate every night. Don't break it. Done. Mm-hmm. Good question. Let's find out. I don't know. Let's find out. So this automation is a lot more reliable than the other stuff. This runs every other minute because the adding things to my DNS. So I just added a CNAME, this one. Am I not? Oh, that's a bit silly of me. Let me just do that. Share screen. Look through my eyes, man. There we go. So I've just added a CNAME for you. Is it visible? There you go. Someone asks a question. So that should be in the DNS already. Yeah, it is. So if I give me the answer, damn it. Oh, yes, of course. Or something. It should be in my DNS. I can't get the show. It should be there. Did I misspell it somehow? Someone asks a question. ACME minus challenge. You should be in my DNS. Why are you not in my DNS? Oh, because you're going to recurse through it and it's not going to find a text record. So that's all good. If I disable recursion, that should all work. But more interestingly, let's just see if we can get a certificate for this for fun. It's on this host, I think. There we go. No, it's not. It's on this host. There we go. Let's issue a certificate for you. I'm sure it's in my buffer somewhere. That's the deploy hook. Come on. Where is my commands? There you are. No, that one. Good. Did I spell it all right? Sure. There you go. Let's see. Maybe this time it'll run faster or it'll catch fire. We will find out soon. I think it will just work. But yeah, but thank you for testing my automation. Yeah. So your use case is split DNS where you don't want the public DNS to see anything. Yeah, I think. Yeah, that makes perfect sense. So yeah, last time it took a couple of minutes. I don't know how long it's going to take this time. With luck, it'll be a little bit faster. It will. I'm pretty sure it'll work. And if it doesn't work, we'll debug it until it does work. So there's about a generous 20 minutes of time left in this session. I'm happy to, keep chatting with Sander, but everyone else is allowed to ask questions too. So, and I'm around all week if you want me to look at your automation and make encouraging noises. Happy to help out. Yeah, you can use Cloudflare, you can use Azure, you can use, there's zillions of them that have already been implemented. So if you pick a public DNS that someone has done the work for you already, that saves you a bit of work. But any DNS will do. The nice thing about DNS is it's a distributed system. So as long as it ends up in the DNS, that doesn't matter how it gets there. NS update in principle works with anything that implements the query, the update query type. It binds. So I just did bind because it's easy. So my certification oracle lives in its own little box. It's got the shell scripts and the DNS server running on in the same jail. So NS updates is basically talking over the loopback here at this, and then and then that binds only serves the certbot zone, which is picked up by my published DNS server. So it's a hidden master for my published servers. And that, that's overly complicated, right? You can run this on your own DNS server. So if it's tsig signed, so if you can NS update your master server, it doesn't have to live on the same machine. It's your attack surface is bounded by what you think the certbot should be talking to. I like it in its own little box, so it's still thinking. Yeah. Well, NSD doesn't support NS updates, I think. So, all right. Yeah, so the NSD script, well, let this thing time out. The NSD script is going to just add a zone stub to your, or it's going to use the inline zone file configuration for NSD, which also works. I just think it's a little bit disruptive. I don't like things writing files on my file system. I prefer to use little protocols like this. There we go. Here's your certificate, I think. Ta-da. That was quick. That only took a few minutes. So if I... yeah, there we go. So this this name has no other records attached to it other than, well, it has no records attached to it at all. So yeah, easy peasy. Yes, Sally. Yes. Yeah, of course. Yeah. So you can by default it outputs, let's scroll up a bit. By default, it encodes the certificates in PEM format, basically for blob, this format. Down a bit. By default, it encodes the certificate in this format, but there's an option to give you the old ASN1, the dir format, which Windows likes. Also, you can use a deploy hook that turns your certificates into anything you want. So you can run OpenSSL BKCS7 if you want to feed your certificate to something which, for whatever reason, only understands BKCS7. So the certbot, it gives you a certificate and you can do with it whatever you like. So if you want Windows, it's done some of the work for you. It can output the certificate in the format for you. If you need a more exotic format, you can do that because you have the certificate. Yeah. I don't know. I didn't write the wiki. Someone did. If it's not there, please update it. I'm sure someone has done it. In all seriousness, I'm convinced that someone has done exactly that, because it seems like a logical thing to do, right? Because Windows machines, you don't want them talking to the naked internet. They cry very loudly if they don't have certificates. So anything you can do to automate it is a sensible thing to do. And I'm sure there's a PowerShell thing you can do that gets the certificate from your Oracle. But yeah, the answer is yes, but the answer to the follow-up question is I don't know. Anyone else? Was this fun? Are we having fun yet? Okay. I thought. Yeah. Right. Yeah, that makes sense. Yeah. So yeah, it's. I hope this was useful. This was just a walkthrough of what I have done. Your network is different, I hope. This is ACME.sh is a simple tool for any number of jobs. If you are currently suffering from expiring certificates, lack of automation, or you're running certbots everywhere on every machine in your network and poking holes in your firewall, maybe take a step back and go, hey, can I stick this in the DNS? Right. So that's all I have for today. Oh. Most of these are open source scripts from GitHub, from the, find my slide, end of slide. Let me throw up this and share my screen again. Dear Zoom, do the thing. We've all become depressingly good at Zoom, haven't we? Here we go. So the acme.sh, I didn't write it. I just like it. And I hope that at some point, the guy who wrote it will talk to me and ask me for a beer, because, you know, he's going to get a lot of beer from me. So this is an open source project. There's a whole bunch of scripts in there, and it's a lively community as well. If you have done something that nobody else has done and you think it is useful to the community, share it with the community. There's new releases very regularly, and the author is very receptive to patches. So if if you have automated something that no one else has automated before, share it, and everyone will like it. The documentation is easy. It's really just stick this shell script in your directory. It has no dependencies at all. It's fiendishly simple to install. All right. Going once. Yes, Kabir. Mm-hmm. Yeah. No, this is a shell script. There is no Python. Yes, this will work on any machine that has a POSIX, not even Bash, an ancient Unix compatible shell implementation. I don't have Bash on my machine. Which Bash? Which Bash? There is no Bash on this machine. It's running whatever shell is in FreeBSD this week. It runs on a naked FreeBSD machine with no packages installed. Oops, package info. Yeah, there are no packages installed on my certification Oracle as dependencies. So it will work on anything. You do have to ask yourself, though, Kabir, your certification Oracle, why not just install a new machine? Right. So this thing is going to it's going to be the source of truth for your certificates. It would be nice if the source of truth worked. So yes, you can install it on an old version if that's what you distribute inside your organization, and you have one image which you built once in 2002 and you've never updated. It will work, but yeah. Yeah. I completely understand. Yeah. But yeah, so again, as I said, this runs self-contained in its own little box. No Python madness. All right. With that, I dismiss you all for the rest of the conference. Social event tonight. Let's go drinking. Ta-da. Nothing caught fire. Nothing broke.